Hi, let's talk about memory today. A memory unit is a collection of registers together with associated circuit needed to transfer information in and out of the registers. So it consists of binary cell, an elementary unit of computer storage that can have one or the other two stable states, and thus it can store one bit of information. This memory cell is an electronic circuit that stores one bit of binary information, and it must be set to store a logic 1 and reset to store a logic 0. Also, this unit stores binary information in groups of bits called words. The communication between memory unit and its environment is achieved through two controls and two external registers. Two controls are read and write. Two external registers are memory address registers and memory buffer registers. To communicate with a memory word, its address is transferred to memory address registers. Before reading and writing information, these are kept into memory buffer registers. In any case, the address register specifies the location of reading and writing. Let's see an example of operations. Read operation. We specify a location to the memory address register. It goes to the location and brings the information to the memory buffer register. On the other hand, when we write something into memory unit, we specify the location in a memory address register, and the information in the memory buffer registers then transferred to the memory unit to the specified location. The random access memory. The data consists of n lines for n-bit words. Data input lines provide the information to be stored into the memory, while data output lines carry the information out of the memory. The address consists of k lines, which specifies which word to be selected for reading and writing. Random access memory. The data consists of n lines. Data input lines provide the information to be stored into the memory, while data output lines carry the information out of the memory. Here is the n data input lines, and here is the n data output lines. The address consists of k lines, which specify which word to be selected for reading and writing. The control lines, read and write, specify the direction of transfer of the data. Here is an example of a RAM. Picture A shows a symbol of 16 into 1 RAM. It means 16 number of words, and each word contains 1 bit. It has a data input, data output, read and write option. If we have 16 words, then we will have 4 number of address lines. On the other side, if we look into the block diagram, we can see the internal circuit. So we need a 4 into 16 decoder, where 4 is the address lines and 16 is the number of words, and each word consists of 1 bit. We have a data input and data output lines and read and write options as well. How a binary cell works. The binary cell has read-write option. It has input and output and a selection. The logic diagram says we have read-write options over here and an input, output, and a selection bit as well. Example of read operation. Suppose we have 1 bit stored in the flip-flop. We want to read it. For this, we need to select this binary cell. If we select the binary cell, it contains 1 and traverse to this point and also this point. On the other hand, if we want to read it, we put a 1 in read. It traverses to the NOT gate and becomes 0 and goes to the AND gate. On the other side, this 1 goes to the output and becomes 1 in this AND gate. In the AND gate, if we have 0, this becomes 0. And from the command of RS flip-flop, if the command is 00, it is a no change. And thus, this 1 is traveling to this AND gate and giving us 1 as an output. Let's see an example of write operation. Suppose we have a 1 stored in the flip-flop previously. Now we want to write another bit inside the flip-flop. For write operation, we'll put a 0 over here, and to select the binary cell, we'll select this from here. That will traverse 1 to the AND gate over here and over this AND gates. We want to save 0 this time. So this 0 is traveling to this AND gate as 0 and negating here and becoming 1 over here. Hence we get 1 and 0. And we know from the RS flip-flops command that a reset 1 and set 0 is 0. So we are rewriting it from 1 to 0. See the construction of 4 into 3 RAM. 4 into 3 RAM means 4 is a number of words, 3 is a bit per word. If we take a look at the binary cell, the block diagram of binary cell consists of read and write, output, select, and the input. If there are 4 number of words, from the decoder, we will have 4 output lines, which is 2 to the power k. Let's take a look. These 4 lines are connected with the selection bit of a binary cell. So each line has different binary cells. If we have 4 number of words, which is 2 to the power k, we will have k number of input address, which are 2. Now we connect the read and write of a binary cell for each number of binary cells. Now we'll connect the input lines. In binary cell, the input lines are coming like this. So we have 3 bits. All 3 bits will have input lines connected like this. Last but not the least, we will have outputs from the binary cell in this manner. So all the outputs from binary cells will go into the OR gate. For example, suppose we want to read from the memory unit, and all the binary cells has information stored previously. Let's see how does it work. To read word number 0, we have to put input address. Suppose we put 00, which will select the line in the decoder 0th number, and this will select all 3 binary cells in the word. Since we have selected read, this will go to the binary cells and enable the option for read. Thus, we can have 1, 1, 0 as the output. Let's try another word. Let's assume we want to read word number 3. Then in decoder, we have to select 3, which is 1, 1 in binary. Word 3. This will select all binary cells in the word. And since we have read for all binary cells, this 0, 0, 1 will go out from the OR gate. Let's try to write something. If we want to write, we have to select write operation and also select address input to which number word we want to write on. Suppose we want to write a number, word number 1. So we have to give the address input for word number 1, which is 0, 1. This will select word number 1's binary cells. Since we have already previously stored inputs, which is 0, 1, 0 in the binary cell, but this time we want to write something, so this will be overwritten. So when we select the write option, this will again go to the binary cell's write options. Now we have to input the data. Suppose we want to write 1, 1, and 1. This will travel from here to the binary cell here, this one here, and this one to the last binary cell. And for that, it will write the new values 1, 1, and 1. Let's talk about memory size. Memory sizes might be specified in bits or byte, and 1 byte is equal to 8 bits. The symbols in uppercase B and the lowercase b. For an example, if we have 2 to the power 28 bits, we can convert it to bytes by dividing it by 8. After that, the calculation comes to 32 megabyte. If we look into the kilobyte, megabyte, and gigabytes power of base 2, we can calculate the numbers. We have a formula to remember, which is capacity is equal to number of words into bit per word. Number of words is also equal to 2 to the power address lines. So together we can write capacity is equal to 2 to the power address line into bits per word. Let's test ourselves. So what is the total capacity of a 2 to the power 16 into 16 memory? Number of words are 2 to the power 16 and 16 is a bit per word. The solution is C. Over here, 2 to the power 16 into 16 bits are given in the question. We convert it and multiply it, and we get 1048576 bits. After that, if we divide it by 8, we get it in bytes. 131072. If we divide it by 1024, we get it in kilobytes. Hence, the answer is 128 kilobytes. How many address lines do we need for a 64 megabyte RAM with 32-bit words? Option A, 23, option B, 20, option C, 24, and option D, 21. The solution is C. We know the formula is capacity is equal to number of words into bit per word. In the question, the capacity is given and the bits per word is given. We have to get the address lines. We know number of words is equal to 2 to the power address lines. Hence, we change the sides and check the number of words here. The number of words is equal to 64 megabyte divided by 32 bits per word. If we multiply and convert it into bits, we have 64 into 1024 into 1024 and multiply by 8 gives it in bits. Divided by 32, we get 16777 bits, and that is 2 to the power 24 bits. This is equal to 2 to the power address lines. So the number of address lines are 24. A block diagram of 1K into 8-bit RAM chip. 1K means 1024 into 8 means 8 bits per word. If we want to draw a block diagram of 1K into 8 bits, it means we have 8 bits input and 8 bits output, which is the input data and output data. And 1K is the number of words, which is 1024. If we calculate the log base 2, we get 10. That is an address line 10. We can give a read and write option and a chip select, and hence we can draw a block diagram of 1K8 RAM chips. Let's try 2K into 8. Comment below. I hope you enjoyed the video. If you have any question, please send an email to me or comment below. Thank you.